Good afternoon to all of you. Uh, Today we are going to discussing on the topic of digital signal processing. But we will discuss the last previous class, summary of last previous class for an about of 10 minutes. Last class we discussed about analog to digital conversion and digital to analog conversion. Means the data is converting from analog to digital. That means digital is numerical. So it is in the form of binary. And digital to analog conversion is the data is converting from digital to analog. In other words, we can also say that the analog signal is converting into digital signal, that is ADC, and DAC is digital signal is converting into the analog signal. Then next, in this, we discussed about the signal. That means applications, right? Microphones. We discussed about and seat belt examples. The thermocouple, the temperature measuring device. Means it converts the thermal, that is heat energy, into electrical energy. Right. Here we discussed in this ADC to DAC. That means in between analog to digital conversion and digital to analog conversion, a digital system, that is microcontroller, microprocessor, is there. That means here a transducer, it sensor or transducer detects the variable from the environment. It sends to the ADC, that is analog to digital converter. The next, the output of ADC is digital signal that is sent to the digital system. Digital system here means a computer or a microprocessor or a microcontroller. Then next, that is the up to according to our requirement, we can go for up to that only to measure any physical variable in digital form. We want, but in industries, we want to this again, this digital, we want to convert into analog. Thereby, that analog, we have to give input to activate any actuating system. So that the output of the, that is the digital signal is from digital system, that is computer. That is the input to the DAC, that is a digital to analog conversion. Here the input is digital, the output is analog. That analog, here analog signal we have to give input to the actuator to activate the system. Then we discussed that is also analog to digital conversion, that is analog signal, and then some sampling signal, sampling and hold circuit. There we can go for visibility. We can go for it is visible. The signal, that is analog signal, should be in this form, and whereas digital should be like in this form, right? Already we discussed it, right? The last class. And the next, we also discussed about digital to analog conversion also, right? And today we are going to discussing about digital signal processing. Digital signal processing. Here in this, see here in the name here, if you see here, here the signal is processing. Signal processing. Which signal here? Digital signal. Here we are saying that signal is processing, right? Signal is processing. Signal is processed. So here, what type of signal is processing here? Digital signal processing. that is a DSP, digital signal. So here the output of this digital signal is from ADC, analog to digital conversion, right? In the analog to digital conversion, the output is, what is the output? Digital. This digital signal, now we are going for signal processing stage. So to get the results accurate, to get the results accurate again. So that is okay, right? That is accurate. So more than that, see here, what we discussed in data acquisition system, data acquisition, DAC. In the DAC, what are there? Here from the sensors, the physical variables, the outputs of the sensor or transducer is the input to the DAC, right? Whatever the physical variable from the sensor is the input to the DAC. In the DAC, what is happening? Signal conditioning, A to ADC, that means analog to digital conversion, and the third one is digital to analog conversion. These ADC and DAC both are the heart for the DAC. That is a data acquisition system. Both for the heart for the data acquisition. But now, what I am saying here in the digital signal processing, in the data acquisition system, what is the here processing going on? One is signal conditioning, another one is ADC, and the third one is DAC in data under the data acquisition system. So signal conditioning already we discussed in unit 2. ADC and DAC last class we discussed, right? ADC and DAC, right? So now the digital signal processing is in between ADC and DAC, and all of you listen carefully. Here ADC and DAC, right? Here the output of ADC is the digital signal. That digital signal again we are going for processing to get more good results, more accurate results. Now again I am repeating, all of you listen carefully. Somebody they will some of the sentences they will skip up. So the next sentence you are not able to understand correctly. Again, I'm repeating all of this here. So here, this unit is data acquisition system. Actual first interesting. Again, I will come from first onwards. Here, a system is there. First, all of you listen carefully. Why you have to go for all this? Just 5 minutes. Please listen carefully. First, a plant or a system, right? Plant or a system, it is having input and output, right? So here in that open plant, here this is a plant, block plant, and this is the right. This is the input to the plant and output from the plant. Whatever the variable from the plant is not our required. So what we have to do, we have to go for arranging the output variable, the feedback element, and then again it goes to the input. So input here, error detector. It detects the error, that is the difference from the output to the input. And then the error detects, it corrects the error. And then again it sends to the plant or a system to get our required one. Here in between the error detector and the plant is the signal conditioning is process or controllers. Some elements we have to incorporate in between error detector and a system or a plant. In between these two, some components we have to run. I already told you. We have to go for signal conditioning or signal processing. In this signal processing, here, all of you listen carefully. Signal processing, what are the elements are there? Maybe some, what I said, this is called data acquisition system. In between the error detector and the plant and system, you can call this a DAC. You can also call, you can add DAC. In the DAC, what are the components here? Signal conditioning, ADC, and DAC. Now you understand, right? So anyway, you can go for further. Otherwise, according to our requirement from the equipment or a device, we can go for the output. It is in the form of a digital. Anyway, you can go. So that means already we can, I given the clear picture in unit 1, that is about open loop and closed loop. Now here in this unit, here what we are data acquisition system. Here in the closed loop system, here it grasps that input. Input is nothing but a variable to the system. So here the sensor and the transducer, it grabs the physical variable and then it gives to the, what it gives to the now to get the signal accurate, what you have to go for. Next step, DAC. That DAC, data acquisition system, it consists of signal conditioning. In the signal conditioning, amplifiers are there, filters are there, attenuators are there, some elements or components which reduce the error, right? Makes the signal correct. And then you have to signal conditioning, what are the ADC and DAC. ADC and DAC. Here, what is ADC? Analog to digital conversion according to our requirement. After ADC, this digital signal processing. After ADC, what is the output? Here, digital signal, right? This digital signal, here the signal is processing. Which signal is processing? Digital signal. You got the clear idea, right? So depth, we are going to depth. That means to get the good results without any error. So now, next one. So what is DSP? Here, somebody mentioned that 3-1 results here. Number 384. To speak out what is your problem? 384. I will unmute you. 384. 384. 384. ఆయన సినిమా చూసుకుంటున్నాడు అబ్బా ప్రశాంతంగా. 384 బెనర్జీ అంట. ఏం బెనర్జీ సినిమా చూసుకుంటున్నావా?
సరే ఆపమ్మది. హలో
బాబు బెనర్జీ, సినిమా చూసుకుంటున్నావా?
సార్ సార్ టీవీ ఆన్ లో ఉంది సార్, అది వేరే వాళ్ళు చూస్తున్నారు సార్.
ఇప్పుడు ఏంటి నీ ప్రాబ్లం ఏంటి
సార్? ఇది 3-1 రిజల్ట్స్ వచ్చినాయి సార్. ప్రిన్సిపల్ సార్ని ఒకసారి అది వెబ్సైట్ లో అప్లోడ్ చేయమని చెప్పండి సార్ ఒకసారి.
ప్రిన్సిపల్ సార్ ఎట్ అప్లోడ్ చేస్తారు? ప్రిన్సిపల్ సార్
సార్ నేను చెప్తానని అన్నారు సార్.
ఓకే. అంటే ప్రిన్సిపల్ సార్ అప్లోడ్ చేయరు. మీరు ఏం మాట్లాడాలంటే అక్కడ ఇట్స్ నాట్ ద వే ఆఫ్ యువర్ ఆస్కింగ్ ఇస్ నాట్ కరెక్ట్. సార్ ప్లీజ్ ప్రొవైడ్ ద రిజల్ట్స్ ఇన్ ద వెబ్సైట్. అట్లా అడగాలి, ఓకేనా బాబు? బెనర్జీ
ఇంకా అడగలేదు సార్, మీకు నేను ఇన్ఫార్మ్ చేశాను సార్, అంతే సార్.
హియర్ ఇప్పుడు ఏంటంటే అంటే నువ్వు అడిగే విధానం కొద్దిగా అంటే మేబీ అంటే అడిగే విధానం కరెక్ట్గా లేదు. సర్లేమ్మా,
ఓకే సార్.
వచ్చాయా రిజల్ట్స్? వచ్చాయా
అంటే సార్ అది యూనివర్సిటీ రిలీజ్ చేసింది సార్, కాలేజ్ చేయాలి సార్.
అంటే మీరు జేఎన్టీ కాకినాడ కదమ్మా, వస్తుందిలేమ్మా, వస్తాయి త్వరలో వస్తాయి. అయినా రిజల్ట్స్ అయినా మీరు సప్లీలో మీ నెంబర్ కొట్టంగానే వచ్చేస్తుంది కదా, చూసుకోవచ్చు కదా మీకు.
లేదు సార్, ఇది వాళ్ళు రిలీజ్ చేస్తే
నేను అడుగుతాను.
ఓకే సార్, ఓకే సార్, థ్యాంక్ యూ సార్.
Here, see here, converting DSP, right? Digital signal processing. Converting a continuous changing waveform. What I said to you, see here, analog, here digital signal processing means here when the digital signal will occurs in the ADC, the analog to digital conversion, right? That means the analog in the ADC, analog signal is converting into digital signal. So here, what a DSP means, converting a continuously changing waveform analog into a series of discrete levels, that is digital. Discrete level. That means discrete levels means this should be, this levels should be more, these levels increasing in a series of this discrete levels. This is analog signal. This is all of you see here. This is the analog signal, right? This is the analog signal, and this is a digital. That means here, what is the DSP means? Continuously changing waveform of, that is analog. Continuously, this is continuous changing waveform into a series of discrete levels in digital. That means in the previous what we discussed, only up to one analog signal we are sampling and hold only one signal, and then we are going further what is happening, right? So, but here it is a continuously changing waveform, continuously changing waveform, analog signal into a series of a discrete. Here, this is a this is step-by-step series of a discrete levels, that is in digital form. From, if you see this box, from this box up to this box, see clearly, this is a series of discrete levels in the digital, right? So that is the DSP, digital signal processing. The next, yes, if you observe clearly again, the digital signal processing, what is happening? The signal is, that means here the digital signal is processing. It is the digital signal is a series of a series of digital levels. And see here in this the analog waveform is sliced into equal segments. Here, this is analog waveform. Here, see here, this is the analog. This is the analog waveforms. What is the next step? This analog waveforms is sliced into equal segments. This first, it comes to equal segments like this. This is the equal segments. All of you see here. Actually, again, I'm writing clearly. All of you see here. First, this is the analog signal. All of you listen carefully. This is the analog signal. All right. Are you understanding? Actually, this is the analog signal. What is happening in the signal processing? It's sliced into equal segments, and the waveform amplitude is measured in the middle of each segment. You see, this analog signal sliced into equal segments. That means having this waveform having amplitude, different amplitude. That means this rectangle, see here, this rectangle, see here, small rectangle, right? So different rectangles having different amplitudes, different waveform. So they're having waveform amplitude. These are the waveform amplitudes. And the collection of measurements make up the digital representation of waveform. And what is this one? The collection of these segments is the representation, digital representation of waveform. Yeah. After this form, what is the thing is here? I already told you what after this form. Here, this is forming like this, right? Right. All this. After this, what is happening? It should be forms like this. Actually, at here, if you draw here, this is a segment, and 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 this is a segment like that. These are like this. These are. I understand now. That means it is the signal is processing in such a way. So here the collection of measurements of all these amplitudes of waveforms, the collection of these measurements make up the digital representation of them. What is the digital representation of the waveform? What I said now. So this is the right. Here, here I'm not writing correctly. Somewhat distance, like this, like this. Okay, right? This is the digital. And see here. Now, if you observe clear, this is the block diagram of digital signal. Again, I will tell you that. Now, in the previous what we discussed, again, I will show the block diagram of the previous what we discussed on this one. I will stop sharing. All of you see here this one block diagram. Now all of you see here. All of you see here. In the digital signal processing, what I said after ADC, the output is a digital signal. That a digital signal is processing. That is a DSP, right? In the previous, I'm stop sharing. What we discussed in the previous. See here, in the previous, it is like this. In the ADC and DAC, here it is a digital system. ADC and DAC. Here, in this, here up to this, we can get the digital signal. That is whatever the physical variable in the numerical form. And then, but in the industries, we have to further go for that digital one, we have to convert into analog, and then we have to give input to the activator. That is the thing. So now, yet here in between ADC and DAC, we are adding DSP. Right. I am stop sharing. All of this here. Stop sharing. I'm adding. Right. So in this, if you see here, if you observe clearly, 1 minute. Here, if you observe clearly, here in the ADC, the output of ADC in the previous digital system, of course, maybe we can also give, after DSP, we can go for digital system. Yet here we can implement a digital system, no problem. But here, that means in between the digital system and ADC, we have to arrange a DSP. The signal is processing, digital signal is processing. So now you got the clear. Here in between and ADC and DAC, we are arranging DSP, digital signal processing. Actually, in the previous, what is their digital system is there? Okay, right. So here ADC and here this is ADC, this is ADC, and this is digital system, and this is DAC, right? So here can go for here. We have to arrange a digital system here. Oh, you understand digital DSP, that is a digital signal processing. Okay, sorry. This is in the, again I'm repeating here, all of you listen here. The previous what we discussed ADC, this is ADC, right? And DAC, right? Okay, and this is a digital system. We added this is digital system, but in between ADC and here we can also add here DSP, digital signal processing. That means the output from the ADC is the digital signal is undergone processing. Here, the analog input, ADC, what is the input of the ADC? The analog input, and the output of the ADC digital input, digital output. That digital output from ADC is the input to the DSP. That DSP, the output is a digital output with accurate levels, discrete levels, a series of discrete levels in digital. So after that, digital output is the input to the DAC again, and again the output is analog output. Here we can also arrange it here the digital system. We can also arrange a digital system. So when you go for up to this level, when we go for further, then we have to go for a DAC and analog output. So this is the other block diagram of digital signal processing. Here, if you see the analog input, again we have to go for further. Further, if there is any small errors are there, we can also, that one also we can go for correction, make it, we have to make it correct. So before this ADC, we can also arrange an analog filter. So what is the meaning of the filter? It filters the unwanted frequencies from a signal. How do you understand? So here, analog here before ADC, further for getting good accurate results, again we have to go for further change. Here we have to, before ADC, we can add analog filter. What is the purpose of the analog filter? It eliminates or deletes the unwanted frequencies from a signal. That is the here the analog. That analog signal is sent to the input to the ADC converter. Now you got the idea, right? So actually this one we can call it as a, in other words, signal conditioning. This signal condition, this filter, in the place of filter, we can also add the name signal conditioning. So here the signal is conditioning. What is the condition meaning? Make correct. So here, I think all of you know that condition because two conditions, three conditions like that. What is that to make that two conditions or three conditions like that? To make the output correct. So if you implement that conditions in any work, then automatically we can get the output. The same similarly here also, signal conditioning means here we can add signal conditioning. I told you filters, amplifiers, attenuators. This analog is one of the filter. It makes the signal correct. That means filter, it eliminates the unwanted frequencies from a analog signal. So that is the input to the ADC, and the similarly same. This is the next. It sends to the BSP and then next to DAC. Here the processor data signal and the output signal, right? Again, this output signal we have to go for reconstruction filter. We have to go for filter to get the analog output correct. This is one block diagram, and this is the another block diagram, right? Of this DSP. Next, digital signal processing examples. 1 minute, I will come. Examples, right? Digital signal processing examples. Digital filtering to remove noise to obtain a clean signal means without any disturbance. So nowadays, from the TV, we can get the sound very clarity. For example, the pictures are completely Dolby, right? All of you know that Dolby, right? That is the digital impact. So that means we can get the sound clarity very much. So by you have to go for these. This is nothing but DTS and DTS Simalo, DTS theaters. So these are implemented this DSP only in their theaters. DSP digital. That means to make the signal very good, to increase the strength of the signal. Signal will be strengthened. Digital filtering to remove the noise to obtain a clean signal. For example, all of you seen in our household appliances, some TVs are there. In some companies like with Sony or some other, we can get the sound very clarity and the picture is also very clarity. Whereas some ordinary without HD, you can go for HD. You can go for HD, you can get a clarity, and then you can get the sound is also very clear. There inside the DSP, digital signal processing is happening. Here, when compared to the Sony TV and some other, if you go for theaters like Dolby theaters, we can get the sound very good clarity. So that means here, what is here, that is the best example. In digital filtering to remove noise, to obtain a clean signal without any disturbance, even small. That clean signal means here, what is the meaning of the clean signal? The signal is strengthened. The signal here, if you see here, the digital filter to remove the noise. Here the signal uh, is not good. Here, if it comes at here a clean signal, the signal is a strengthened. Here a weak signal, it is a weak signal. Remove here the signal is a noise signal means it's a weak signal. So to obtain a clean signal through DSP, right? DSP, digital filter, right? We can get the clean digital signal, digital noise input, right? That is one of the example and applications. Here, if you observe clearly at here, this noise signal. If you observe it here, this is the noise signal, right? See here, here the amplitudes of each level, this level and this level, the amplitude varies. Here, see, this is the y-axis is amplitude, right? Here the amplitude is varying. But here, if you see it here, clean signal, if you observe the clean signal, after this signal is sent to the digital filtering, this signal is input to the digital filtering, and we can get the output signal like this. So then almost all in the signal, that means it is filtered. The unwanted frequencies from the signal are eliminated. We can get the signal is in a clean signal. Now you got the right. The next some applications, right? So here this DSP is used in ECG. I think all of you know that in medical. So is there any malfunctioning in the heart? Malfunctioning, with the help of the ECG, we can find out. Here that the signal, depending upon the signal waveforms, the doctor can easily identify is there any malfunction is there or not, disorders. So here in this, see here the patient is on the bed and then it is a testing, right? Here these are the inputs. Given from the human body with 60 hertz interference, right? And see here, this is the input to the amplifier. Amplifier is nothing but what I said to you, signal conditioning only. This completely it is a DAC, the data acquisition system, signal conditioning, ADC and DAC, right? So this the input is given to the pre-amplifier. That means amplifier. It amplifies that signal, and then again it sends to the digital notch filter for eliminating 60 hertz interference frequency. That means it eliminating 60 hertz, means up to 60 hertz, it will eliminate all the frequencies from a signal. This is also a filter, and here we are arranging one amplifier and here one arranging filter digital, and then we can get the digital signal, right? These processing we can call it as a digital signal processing. We can call it as a DSP. The processing is going on, the signals. Lastly, we can get the ECG. I think all of you know that ECG. So recorded that the removed 60 hertz interval. That means the removed, that means below 60 hertz frequencies from your signals are removed. That means those are unwanted signals. So lastly, we can get the ECG in a good form through digital signal processing. So this is one of the best application of DSP. ECG. ECG means electrocardiography. Electrocardiography. Now it is clear. The next example. See here in the digital image enhancement, what I said to you about TV, right? So if you go for more than TV, then you have to go for theaters, DTS theaters, right? So here, so this is the original image. This is the original image. With the help of the DSP, we can enhance the image like this. See here, Even here in the, this is a completely water, so the, what is the mirror image of this tree is not visible at here, am I right? So if you see it here in the water, so the mirror image of this tree is visible at here clearly. Here, any image you can enhance in a bright, so very accurate image through DSP, digital signal processing. Even if you go for Photoshop, that means maybe my what is that software, or we can go for any photo studio. So they will, for example, you would, they will take your photo and then they will enrich the image of your whatever the image capture. They will enrich that image in a good form. So that is also one of the application. And speech coding and compression also. Speech coding, even see, for example, I am talking to you. Sometimes I will go, sometimes it should be not in uniform. Maybe sometimes the pitching is high and the pitching is low. It should be non-uniform about my signal. What I'm talking with you, right? I am giving delivering lecture. So this should not be in a correct uniform. Sometimes the pitching is high, sometimes the pitching is low. That means this speech may be coding and compression in uniform. Choose మనకి in the railway stations or some other stations, the announcement is very, very good. So that first somebody they given speech, that speech is going for coding and compression. We can get the speech very output in with the correct way, correct way. మనకి చూసే ఉంటారు మా రైల్వే స్టేషన్స్ దగ్గర అనౌన్స్మెంట్స్, సమ్ ఆఫ్ దేర్ అనౌన్స్మెంట్స్ ఇస్ వెరీ, వెరీ గుడ్. So actually one member already the speeching, that speeching we have to go for coding and compression. We can get the output of the speech in a good manner. The next, right, and next, vibration signature analysis for defected gear tooth. So in the gear tooth, if you observe, sometimes any particle from the gear tooth is broken, it's minute. So what happens, the vibrations, we can get more vibrations when it is in running, right? So here the two gears are meshing together, right? Meshing together, right? So for example, in the gears meshing, what happens, the continuous, due to continuous running hours and hours together with some mechanism. So what happens, the gear tooth will gets damaged, more small particles will be get down. So what happens, there the whatever the meshing will not proper in meshing. So thereby some, of course, maybe it should not be in correct meshing. Also, some we can get the vibration right around. So these vibrations, where the defect occurs in the gear tooth, that one we can find out through DSP, digital signal processing. We can find out. Same as our human body, if there is any malfunctioning of heart, we can find out through ECG. Same similarly in the machines also, there is in the, not only in defected gear tooth, any. This is example I'm taking. Any vibration, more vibration causes due to some defects inside. That defects we can find out through DSP. I don't understand. There is no difference. All of you listen carefully. In our human body, there is a malfunctioning of auto. We can, with the help of the ECG, we can find out the defect. Right out, right out. That is, this ECG will go so through the DSP process. Same similar in a machine or any, there is a vibration, more vibration compared to that previous. So we can go for that vibration signal, any defected. We can go for there is any defected is there. We can find out through this DSP. Right? Or understand? Right. Right. So tomorrow we will discuss much more. So today the absentees are more, right? So again, I will discuss more applications on DSP. Very, very good applications. Very, very, I will discuss good applications in the next class. There are so many applications are that the technology is deviating, right? This DSP nowadays, more applications, wide range of applications, which is mingled with mechanical, బాబు 385 నీకు ఆప్షన్ పెట్టేస్తున్నాను. సో వెన్ ఐ ఆస్క్ యూ దెన్ ఓన్లీ యూ కెన్ టెల్. అంతేగాని ఇష్ట ప్రకారం జస్ట్ క్లాస్ అయిపోగానే ప్రజెంట్ సార్ అని పెట్టేసేది. ఆర్ అండర్స్టాండ్? సో రెస్పాండ్ యువర్ అటెండెన్స్ వన్ బై వన్. Uh, 301, right? 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18 to 19, 20, 21, 22, 23, 24, 25. Okay, 22. 25, right, 22, 26, 28, right, 26, okay, right. 27, 29, okay. 30, 31, 32, 33, 28, okay. 33, 35, 36, 305 on. 36, okay. 37, 38, 39, 41, 41, right. 42, right. 43, 44, 45, 46, okay. 47, 48, 48, 49, 50, 49, 50, 52, 53, 54, 55, 56, 60, 60, 61, 62, 63, 64, 65, 66, 67, 68, 68, 69, 69, 70, 73, 74, 75, 76, 77, 77, 77, next 78, right. 78, 78, 77, okay. 78 option. 79, 79, 80, 81, 83, right. 84, 85, okay, right. 83, 84, 85, okay. 88, okay. 89, 90, 90, 90, 91, 92, 92. Okay, okay. Lateral entry 1, 17 over 16. Lateral entry. Lateral entry 1, 2, 2, 3, 3, 4, 5, 6, 8, 9, 9, 10, 10, 11, 12, 12, 13, 14, 15, 16, 17, 16 number. Right. 10, okay. 16, 17, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26, 26, 27, 28, 29, 30, 31, 32, 33, 34, 34, 35, 36, 37, 38, 39, 40. 41, 43, right. Okay. So here the option is 11, if regular 11, 15, 17, 19, 27, 39, 48, 49, 50, 56, 64, 61, 60, 61, 64, 67, 73, 74, 75, 78, 80, 81, 90, lateral entry 2, 3, 4, 5, 9, 16, 17, 21, 22, 23, 24, 26, 27, 30, 33, 34. So some of the members, they came over here. So I will give, I will see that numbers and then I will give the attendance. Some of them, they came to the college for submission of mother Aadhaar card Xerox. So I received around 15 members. Okay, right? I will give the attendance. Okay, right? So already they are in the college. I will tell you the mid exam 17 by 369 present. Okay, thank you all of you. Okay, I will tell you mid dates in the WhatsApp group. Thank you all of you.